Okay, we're now going to start to look a little bit more deeply into why we might even consider looking at switching the order of integration. What benefit possibly could there be? But first, let me remind you of something. Watching every episode does not give you the ability to do the problems necessarily yourself. At this point in time, the first set of assigned problems in the book are basically asking you to just integrate. Most of the integrations are not particularly difficult. You're just trying to not make too many, if any, errors at all. And my additional directions are to make sure you are sketching the region whenever possible. There are a couple of regions that are beyond our ability to graph maybe, but nearly all of them you can sketch. So let me show you an interesting case. We are going to take this region here between the x-axis and these graphs. The whole thing here is our region. And we're going to use the integral to calculate area. As a reminder, if there is no function in here, we can think of this as area. You have to go back a few episodes to see that, but you should do that. So we're going to set up both orders of integration. So that means we'll start with dy dx and see what we can make of it. And remember, when we integrate, this last integration here must have constants. So that means when we start looking at this process, let me just slide this up here, and we look to set our boundaries, we're going to have left to right boundaries in terms of x that have to be constants. And we can see here from left to right that x begins its journey at -4 and then goes across to +2. Now, don't get all excited. Our first little hiccup's about to take place. The bottom boundary, and I'm going to use our written description before I use the algebra description. We're going to have y equals boundaries. The bottom boundary is definitely the x-axis all the way across here. And the equation of that is y equals 0. The top boundary, again, I want you to think Calc 1 rectangle style here. As we go across, the top boundary is a line. This line, we'll come back to that momentarily. But then suddenly it switches, and the top boundary over here is a parabola. This boundary switches from a line to a parabola. This is problematic. In Calc 1 and then in Calc 2, we discovered that when that took place, you would have to set up two sets of integrals to make this happen. So let me just slide a bit here. We're going to move back and forth on our portable screen. We're going to have one integration that will represent the triangular region here, and another integration that will represent what's under the parabola here, and they must be added together in order to make this work. All right, so first things first, there's an error to correct. When I was going from left to right, as I go from left to right, when I get to x is 0, this is the place where the top boundary changes from a line to a parabola. I have to get rid of this 2, and I have to call that x is 0. And then I have to follow it with the next set of integrals is going to go from x is 0 to x is 2. They have to be constants. But from -4 to 0, we've got a triangular region, and from 0 to 2, we have a parabola region. So I have to separate these from -4 to 0 and from 0 to 2. The bottom to top boundaries are going to go from the x-axis to the line, and then from y equals the x-axis to y equals the parabola. Yes, I know not many people would write this. You certainly won't find it written in a book. But I'm trying to set myself for knowing I need a y equals equation, and I only know the verbal description of it. I haven't figured out its DNA yet. Figure out how it makes it work. All right, so this so-called line up here. Y-intercept is 4, slope is 1. I wrote it y equals 4 plus x because I think I've been doing too many parametric equations. It just felt natural. Y equals x plus 4 is the same equation. If I take this line, and I'm going to slide here for some scratch paper, y equals x plus 4, that is the top boundary here for this region. And if I set up my first integral, x goes from -4 to x is 0. Y goes from 0 to x plus 4. This becomes the setup for the region that is that triangle. And then here, x goes from 0 to 2. And y goes from the x-axis, y is 0, to y equals the parabola, which is given to be 4 minus x squared, if we were to come back up in the list. 0 to 4 minus x squared. It takes 2 sets of double integrals to make this work for us. Now, according to the directions, I wanted to set up both orders of integration. So let me do a change of page. Remember, you have a pause button. You can always go back and look at this first solution. All right, back to our picture again. And we're going to switch our problem to dx dy. And please recall that this integral, this last thing we do, has to be constants. So I'm going to be thinking of this as what's going on from the bottom to the top and from the left to the right. All right, the bottom of the top would be y equals boundaries. Left to right would be x equals boundaries. And let's look at it. I need my y boundaries to be constants. The y value goes from 0 to 4. That's the bottom to the top. I'll write it in. I've got a pencil. I can erase. Now, let's look at it from left to right. It looks like all the way from the bottom to the top, the left boundary is going to be this line, and the right boundary is going to be this parabola. No matter where we are from y equals 0 to y equals 4, the line is the left and the parabola is the right. There's no jumping between different regions. So I can paraphrase it. X equals line to x equals parabola. And like I said a moment ago, I don't have the algebra for those nailed down, but I need them to be x equals boundaries. And this picture clearly shows that the left's always the line and the right's always the parabola. So I should be able to set this up as one set of double integrals, dx dy style. So this will be y equals constants and x equals maybe some variables. So let's see what we can do. The line y equals x plus 4. If we solve for x equals, the x is y minus 4. That is going to be my left boundary here. The parabola y equals 4 minus x squared. If I attempt to solve this for x equals y minus 4 equals negative x squared. X squared is 4 minus y. X is plus or minus the square root of 4 minus y. And we know that the plus is the one we're interested in. Scroll for it, because we're looking at the right half of this parabola. We're not looking at the left part of the parabola. That makes this my right-hand boundary. Positive square root of 4 minus y. And my y boundaries went from 0 to 4. And there we have it. Double integral, but only one of them, for area. The idea being, it's more convenient to have this version than the version that took two sets of integrals. Integrating this one would be, or should be, a little bit easier, we would think. All right, time for some practice for you guys. There are problems like this in the first two sections of the chapter. Look for them, they're fun.